Just a little bit of vocabulary, or on the back of the front page, I think, is where we left off. So I know we jumped around a little bit. Let's talk about a little bit of vocabulary here. Oh, I need to turn the smartboard on, huh? But the first word, the first couple words you guys should know. What do you call a shape where all the sides are equal? I think I heard it. Equilateral, okay? That's your first term. A polygon is equilateral if all of its sides are congruent. Equilateral. Okay? And what do you call it if all of its angles were congruent? Equiangular. Very good. Now, when we dealt with triangles, those two words always went together. Well, any other shape besides a triangle, you can actually have one without the other. Now, if you happen to have both all the sides and all the angles the same, then we call it a regular polygon. Okay, so I always tell people the first shapes you were probably ever introduced to when you were a toddler, like those little blocks or little shapes or whatever, were probably all regular polygons. So anything on that poster over there, well, okay, not anything, but like this, the square, the pentagon, the hexagon, all these down here, those are regular shapes, meaning all the sides are the same length and all of the angles are the same measure. So down here, what they've done is given you kind of an example of each. So these are all hexagons. The left one is an example of an equilateral hexagon that's not equiangular. Okay, so they don't have to go together. So on this first shape, the sides are all the same, but the angles are not necessarily the same size. And I know that's true because if I look at like this angle and that angle, those are not the same size. The second hexagon is equiangular, where all the angles are the same size, but not equilateral. The only shape where they automatically go together is going to be a triangle. There's no way to have one without the other for a triangle. Now, this last shape, this hexagon here, this is going to be a regular hexagon. So anytime you see that word regular, real creative with the vocabulary, I know. Anytime you see that word regular, that means all the sides and all the angles are the same size. So I always tell people regular, it just kind of means like it's a perfect shape. It's a perfectly symmetrical, everything's the same shape. So your stop signs are an example of a regular octagon, regular polygon. Okay, and all we're going to do with this is just recognize some of these congruences and help us figure out how to find some angle measures with them. So up here it says a home plate for a baseball field is shown. Is the polygon regular? Explain your reasoning. So right off the bat, is this regular? Now again, regular means that all the sides and all the angles are the same size. So is that a regular polygon that's showing? No, I would agree it's not. Now, I don't know anything about the side lengths, but look at these angle measures. 3 of them are 90 degrees. And the other 2, E and C, are those 90-degree angles? No. So I would just write for my explaining my reasoning that not all the angles are the same. I'm pretty sure not all the sides are the same either. Like, I'm pretty sure side AE is not the same size as A to B. I don't know that for a fact, but I do know for a fact the angles are not the same. And then the next part says find the measures of angles C and E. Now, those arcs up there mean they're the same. So whatever angle C is, angle E has to be the same. So I'm just going to call them X degrees for right now. And I'll be able to figure out how big those angles are. But the first thing I have to know, and this will be a good review from last week, is what those 5 angles even need to add up to. Because normally if it were a triangle, I would add what I know and subtract from 180. But remember, from last Friday, that the angle measures don't add up to 180 because it's not a triangle. Who remembers how we figure out what the angles are going to add up to here in this pentagon? What's that magical little formula we learned last week? Faith? absolutely. N minus 2 times 180. How do we find the total for what pentagons add up to? Or for any polygon that's convex? N minus 2 times 180. What did N represent? The number of sides it has. So in this case, what is our N going to be? What would we plug in for N if it's how many sides it has? 5. Very good. So we're going to take 5 and plug that in for N. And I'm going to come around with calculators because we will need one. I've got that. And we're just using the same note sheet Grace did last week. All right, 5 minus 2 is 3. 3 times 180. Who can raise their hand and tell me what that equals? Michaela? 540. So for any pentagon, it needs to add up to 540 degrees. And so how I'm going to find angles C and E? Well, let's start by taking away what we know. How many 90-degree angles are there in that home plate? There's 3. So let's take 3 90s away from that. So we're going to take 540 minus 90 minus 90 minus 90, or that's the same as 540 minus 270. And what's 540 minus 270? 270. Now, that's what's left over right now. And C and E need to add up to that number. C and E need to add up together to 270, and they need to be congruent. So at this point, mathematically, what's going to make sense for how we find the measures of C and E? Anyone besides Michaela? Michaela's answered a couple times, so I appreciate it. Tristan? Exactly. Just go ahead and cut it straight in half because they're supposed to be the same measure. So what's 270 cut in half? 135. And that makes sense to me because angles C and E are both obtuse angles, so 135 seems to visibly make sense. Okay. As another little review from last week, the exterior angles worked a little bit different. So the N minus 2 times 180 is what the inside angles add up to. How about the outside angles? What did they always add up to on the outside, no matter what? 360. Very good. Okay, so we're almost done with this. I don't know, where did we leave off here? Yeah, we did these two and then we didn't go any further, right? So this says finding angle measures in a regular polygon. So again, what does regular mean? Parker? Very good. It's equilateral and equiangular. So in other words, all the angles are going to be the same size. So it says find the measure of each interior angle and each exterior angle of a regular dodecagon. Let's start with the interior. Now, let me use my triangle as a reference again. In an equilateral triangle, how big was each angle? 60, Lakin. Very good. Where did that number come from? Where did 60 come from? Luke? 180 is what they add up to. Where did 60 come from? Right? They were each 60. And where did that number get derived from here, mathematically? Connor? Very good. You took the total and you divided it by how many angles you had. If you have a total amount and it needs to be evenly distributed, then you're taking that total and just dividing it by how many angles you're distributing it to, right? So that's kind of how all of these are going to work. You're going to take the total degree measure that it needs to add up to, and you're going to divide by the number of angles that it has. Okay, if you want it to be regular and you want it to be equiangular like that, and all the angles to have the same measure, you're just going to divide by how many angles that it has. So let's start by finding, for a regular dodecagon, what they even add up to. Now, dodecagon, how many angles is that? What did you say? 12. Very good. So that means our N is going to be 12. So when I do this little bit over here and find the total that it's going to add up to, I'm going to plug in 12 into my n minus 2 times 180. Now remember, that n minus 2 times 180 only gets used for the interior angles. Exterior is going to be a little bit different. And we're going to divide by how many angles it has, which is 12 angles. So what is 12 minus 2 times 180? Well, 12 minus 2 is 10. What's 10 times 180? Anytime you multiply by 10, you're just like tacking a 0 on the end. So 1800. And we're going to divide that by 12 angles. There's 12 angles in a dodecagon, and we need to evenly distribute this 1800 degrees to each one of them. It'd be like me having $1,800 and having 12 children that I had to split it evenly between. I would never in my life have 12 children, just for everyone's information. But anyway. Okay? 1,800 divided by 12 is what? 150. So in a dodecagon, if you want it to be regular, each angle would be 150 degrees if you evenly distribute it. You're taking the total that it has to add up to, which depends on how many sides it has, and dividing it by how many angles it has. Okay? The exterior works a little bit different and it's easier because the exterior always adds up to a certain number, which we said was 360. Very good. So for the exterior angles, it's just always going to be 360 and then divided by how many angles it has. And if it has 12 interior angles, it has 12 exterior angles. So in this case, we just always take 360 divided by 12. 12 again is because it's a dodecagon, so it all depends on how many angles it has. And what's 360 divided by 12? 30, and that's what each exterior angle would be. We'll try it again with the 45 gon.
And they should, to check yourself, they should always add up to 180.
Yeah, I wasn't.
It's
okay. That's okay.
Right
Yes,
face.
yes.
I'm so sorry.
It's all right. We're going to do it again. But yeah, they are always going to add up to 180, and I will explain why in just a minute. Not a problem. Okay, let's try it one more time here. Now, on this one, what is our n going to be? 45. This is a 45 gon. Let's start with interior. We take the total degree measure divided by the number of angles. How do we find the total degree measure on the interior? I can't hear you. What? N minus 2 times 180. So in this case, that's going to be 45 minus 2 times 180. Which is 43 times 180, and what's 43 times 180? Probably a large number. Remember how many sides it has, it's going to keep getting bigger and bigger and bigger. So what's 43 times 180? 7,000, nice and loud, because I can't hear.
7,700.
Like that?
Yeah.
Okay. And divide by how many angles it has. How many angles does a 45 gon have? 45. Mm-hmm. Yeah, make sure you use the original n, not after you've minus 2. So that's going to be a number really close to 180 if we do this right. What's 7,740 divided by 45? 172? And then exterior always adds up to 360, so we just automatically put a 360 there, and then they still want each one, and that's the key word in this problem. The word each means I want you to tell me how big the individual angles are. So we're going to divide by 45, and what's 360 divided by 45? 8, just a teeny tiny little 8-degree angle. Okay, now, Mr. McCrona just said that your interior and exterior angle should be adding up to 180, and they should. And let's talk about why. I'm going to use my triangle again as an example, because that's just the easiest thing for me to draw. If you think about An interior and exterior angle put together, what do they make together? 180 is not an object, you guys. 180 is a number. So what do they make together? A line. Very good. And lines, linear pairs, are always 180. So it should kind of make sense that your interior and exterior have to add up to 180 together because they'll always make a straight line. So now that you know that fact, that might make this process a little bit easier for you, and that's fine. If you don't know what I'm alluding to, what I tell people is if you can understand they should add up to 180, sometimes it's easier just to find the exterior first and then subtract from 180 to find the interior. But I want you to still understand the process for where the interior is coming from. Okay? Last little thing here then is going to be working backwards. This is probably the one that takes the longest. Exterior will once again be easy. But let's talk about the interior angles. It says find the number of sides for the regular polygon described. Each interior angle has a measure of 156 degrees. So let's think about the process we just used to find each interior angle. We took the total degree measure, which was that n minus 2 times 180, and we divided by the number of angles it was going to have. So in a formula sense, if we take the total degree measure divided by the number of angles it has, we're taking n minus 2 times 180 for however many angles it has, and we're dividing by n, how many angles it has. We're taking the total degree measure on the inside and dividing it by how many angles it's going to have. Now, we don't know n in this case, but we do know how big the angle is going to be. It's going to be 156 degrees. And now we have an equation we have to solve, okay? So here's where, if you're great at algebra, we'll be good to go. If not so much, it might be a little tricky for you. The first thing I would do always on a problem like this, always, step one for me is going to be to get rid of that fraction by multiplying by the denominator, right? If I had an equation that looked like this, I would be able to multiply by 4 on both sides and get rid of the fraction, because the fraction is just division, right? So what is the denominator here? N. So I'm going to start by multiplying by n on each side. Because that's going to eliminate the fraction and make this a little bit easier to look at. So now what I have is n minus 2 times 180 equals 156n. It didn't disappear, it just got multiplied to the other side. But don't let it just drop out of the picture, because that's going to change the value of the whole thing. Okay, now, on Friday's notes, we were able to divide by 180 on both sides. That's not going to be the case here, because now you don't have just a single whole number on the right side, you have this n involved. So we're going to go ahead and distribute that 180 across the n minus 2. And now it's a two-step equation where you're going to move your n's to one side and leave your constant on the left. Okay? So again, I'm going to leave the negative 360 here because it's already on its own. And what's 156 minus 180? What is it? Negative 24n. And as far as the negatives go, as long as you remember the fact that n should always be positive in this case, because you can't have a negative number of sides, the negatives aren't terribly important, I would argue, but divide by negative 24, and the negatives are going to cancel, so really what's just 360 divided by 24? 15 sides? And And that's how many sides. If I had a regular 15 gone, each angle would be 156 degrees. So here's the deal. That might have seemed like a really complicated process. And it is a little complicated. But I'll tell you, on your homework and on any other problem like that, literally the only thing that's going to change is this number right here, the 156. That's the only thing that's going to change. The entire process is going to be exactly the same. The left side is going to be exactly the same. It'll always come out to be 180 and minus 360. The right side is the only thing that changes. Now, exterior angles, I'm going to show you what it looks like first, and then the process is actually quite easy. So again, to find how big each exterior angle was on the last slide, we took 360 divided by the number of sides. Now, in this case, I don't actually know what that number is, but I know the degree measure is going to come out to be 9 degrees. Okay? So technically, what I would be doing on each side to solve is same thing. Get rid of the fraction by multiplying by n. But all that does is just move n to the other side. And to solve for n, you're literally just dividing by 9. So the exterior angle is really, really easy because it gets solved the exact same way as the last time. You just take 360 divided by the number that they give you, and that's going to give you how many sides it has. So what is 360 divided by 9? 40. So that figure would have 40 sides. And those were two separate problems. Okay, so let's just go ahead and do I think the homework problems maybe together as a group real quick, or at least a couple of them. And then we need to get into the 7.2 notes a little bit today at least, so that we're not saving it all for tomorrow. I wonder if it's going to let me write on it today. So how about, how about we do number 14 together. I'll have you guys do 15 on your own as part of your homework, and then we'll look at 16 and 17 together, okay? So number 14 again says find the measure of each interior angle and each exterior angle of the indicated regular polygon. So every single angle is going to be the same here. Let's just do exterior first because that's the easiest. Exterior angles always add up to what? 360, and I'm going to take 360 divided by how many sides it has or how many angles it has, which is 18 in this case. So what's 360 divided by 18? What is it? 20 degrees? Okay, so if we do the interior correct, it should come out to be 160 because they're always going to add up to 180 together if we do this right. I'd like you to know the process, so yes, even though I know the answer is going to be 160, let's just practice the process so that our minds can kind of lock in how to do it. For interior, we first have to do the 18 minus, I'm not going to use green because that's hard to see. I'm first going to do the 18 minus 2 times 180 business, and then I'll take whatever number I get and divide by 18, because that's how many angles are there. 18 minus 2 is 16. Who can raise their hand and tell me what 16 times 180 is? 16 times 180. Someone help me out. Aaliyah? 2,880. And then divided by 18. Are we getting 160? Hopefully. See a confused look in your eyes. Were you confused for a second? Okay. Good. And then they'll do the same thing on 15, except you'll replace 18 with 90. Okay? And you could get decimals, by the way. If you get a decimal, don't fret. It might be a decimal. I don't actually know off the top of my head right now, but it might be. Let's look at 16 and 17 together real fast. So 16 says each interior angle has a measure of 165. So they're saying, okay, whatever n is, after you plug it into your n minus 2 times 180 and divide by how many angles it has, so the top of the fraction is the total, the bottom of the fraction is how many angles it has. I don't know what n is, but I know that number is going to come out to be 165. So this process is going to work exactly the same as the notes. So if you have the notes in front of you, the only thing that changed is instead of a 156, now it's a 165. But it's literally the same process. So what was the first thing I had to do here to solve for n? Times what by both sides? N times it by n on both sides. And I'm going to run out of space here. Now, it didn't go away. When you multiplied, it wasn't like, poof, magic, gone. It just moved to the other side. So, but don't let it eliminate, because then you're going to get weird answers here. And then I feel like you should be able to solve from there. Use your notes as a reference, but that at least got rid of the fraction for you. Distribute that 180 through. Now, 17 was a little bit easier. 17, just one operation we have to do here to figure out how many sides it has when it says exterior. And that's the key word there, exterior. Who can remember what we have to do here to find how many sides it has? Luke? 360 divided by 6 degrees. That's going to tell me how many sides it has. Which is 60 sides. So you guys on your own, besides the rest of the worksheet, need to finish 15 and finish 16 on your own, and then anything else in the 7.1 you haven't finished. Now, I would like to start this. Let me look. Yeah. I'd like to start 7.2. Yeah, I want to start it a little bit. We'll see how far we get.